talk about resistors in parallel, and in our illustration we have three resistors here: resistor R1, resistor R2, and resistor R3 connected in parallel, and for them to be in parallel they must be connected across the source voltage here. And for resistors in parallel, voltage is the same. Voltage is the same, meaning that the voltage here across R1, the voltage across R2, and the voltage across R3 are the same, and they are equal to the source voltage. And for current now, I, which is the source current here, will be equal to the current I1 plus current I2 plus current I3. Now I'm going to write I is equals to I1 plus I2 plus I3, and that is according to the Kirchhoff's current law. Again, from Ohm's law, current is given as voltage over resistance. This is the circuit current. It's supposed to be the source voltage over the circuit resistance. Let us call it this equation 1, and this equation here Roman 2. Now we have I, which is V over R. What about I1? How are we going to get current I1, which is the current flowing through resistor R1? Now for I1, it is going to be equal to the voltage here, which is the same as the source voltage. So V over the resistance, which is R1. And for I2, we do the same. So we are going to get it, the voltage here, which is the same as the source voltage, V over the resistance here, which is R2. And for I3, we do the same. The voltage here, which is the same as the source voltage, over the resistance R3. Now, we are going now to use equation 1 to substitute all the other equations here, whereby we have I, which is given as V over R, and for I1 we have V over R1, for I2 we have V over R2, and for I3 we have V R3. Now I'm going to write, instead of I, I'm going to write V over R. V over R is equals to I1 we have V R1, for I2 we have V R2, and for I3 we have V R3. So I1 we have V plus over R1 plus V over R2 plus V over R3. Now we are going now to factor out the common factor there. You can see V is appearing in each term there, so we are going to factor it out. V into 1 over R is equals to, the V is common there, so V into what remains here is 1 over R, 1, plus 1 over R2, plus 1 over R3. And V now is also common on the right hand side. It is appearing there, and also it is appearing on the left hand side. Now we are going to divide V on both sides for it to cancel out. Now what remains is 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is now the total resistance. Therefore, 1 over RT is given as 1 over R1 plus 1 over R2 plus 1 over R3, and if we have more resistances, we keep on adding them up to the last one. So this is now the final expression.